Welcome to the Digital Amateur Television Experimenters Night. This is VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania. Amateur radio is a worldwide hobby that has many different aspects. Digital television is just one of the many modes and areas that are covered. Maybe you're interested in becoming involved in the DATV Experimenters Nights. Do you realise that you do not have to be a radio amateur or need any ATV equipment to participate anywhere in the world? Also participate in the night by coming up to the Queen's Domain clubrooms. Yes, right on top of the Queen's Domain in the heritage-listed Coast Wireless Station. You never know, we might get you in front of the camera or behind, doing one of the many roles during the night. We get underway with our program on a Wednesday night from 7:30 p.m. local time. We'll see you soon. This is VK7 OTC.
Okay, this is VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our DATV Experimenters Night. And I've got Rex, VK7 MO, in the studio. Hello, Rex.
Hi, Justin.
How you going?
Pretty good, yes.
Now, Rex has got some very interesting presentations for us shortly, so stand by. Just before we get underway, I wish to acknowledge Tasmanian Aboriginal people as the traditional owners of the land upon which we're presenting tonight, and pay my respects to elders past and present, and for they hold the memories, the knowledge, the culture and hopes of Aboriginal Tasmania. Now, the reason I've got Rex in the studio is on Sunday we had a special event.
We sure did. For those who are not aware, we run a 23cm QSO party every Sunday morning straight after the broadcast. And it turns out that we started it on the 6th of December 2015. So this was our 10th anniversary this Sunday. 1 day difference because
Okay.
it's still got to be a Sunday. And over the years, we've had the numbers build up. The median level is about 15. Sometimes it drops back to 11. Occasionally it gets up to 17 or 18.
Yep.
But for our 10th anniversary, we did a lot of promotion.
We did.
And tried to get as many people as possible to come on. There are, in fact, 49 stations who are capable of getting on 23 centimetres here in Hobart.
Which is amazing by itself, actually.
It is.
Given how many we started with.
That's right. And that's built up as a result of running workshops to build Yagis for 23.
Yep.
And also the availability of these little Bulgarian transverters that can be GPS locked and work really well on 23 centimetres.
That's the SG Labs.
Yes.
Yep. Yeah.
And they do have either a 25 or 50 watt PA that can go with it. Yep. So with one of those, you can have a pretty healthy a 23 centimetre station.
Well, truly.
And the other thing that's come in the last, I think, about 5 years is the IC9700.
Yep.
Which is a radio all set up for 23, 2 metres, 432 and 23 centimetres.
23, yep.
And a fair few people have got those. I'd say 40% have got those, 40% have got the Bulgarian,
yep.
And a few have got a few other Kenwoods
and ICOM, old ICOMs.
Yeah, IC 910s.
Yep. And 1271s.
Yeah.
I see 1271s. I have the old clunker.
Yeah.
Yes.
So, for our 10th anniversary, we tried to make this a special event, and if we just go on to this
now,
slide.
Can I just before we go on to the slides, just explain to those people who we've got online. We've got a pretty unique setup in Hobart.
We have.
For a couple of reasons.
Yes. To make a QSO party work without people having to turn their antennas all the time, what we mostly do is all point at Mount Wellington and reflect back. And that means you can have a fairly high gain antenna and you can hear most people without turning your antenna. Now, some can't see Mount Wellington.
Yeah, down around the corner and a few other things. But most can.
Most can.
Most can. Yeah.
And some reflect off
Mount Rumney.
Mount Rumney.
Across the other side of the river.
Yeah. Steve O has two antennas and switches between Mount Rumney and Mount Wellington.
Yep.
Dave, Delta Mike, somehow reflects off the broadcast towers down south.
Okay. Not Chimney Pot Hill. No.
The MF ABC towers.
Oh, okay. Yeah. Down at Lauderdale.
Yes.
There you go. I love it.
And somehow gets most people.
Okay.
And the other thing that means you don't have to do continuously tune to resolve stations who are not necessarily all on exactly the same frequency, because unless you're GPS locked to 1296, you can be a KC off easily. And that would mean you'd always be tuning and resolving, and by the time you'd resolved them, they'd finished whatever they had to say.
And you'd have to go back to whoever you were listening to before. Yes.
That's right. So we use FM, and FM can tolerate at least a KC. In fact, it's not too bad with 2 KC offset. So the special role of our passive repeater called Mount Wellington makes this all possible. And so over the years, we've now racked up the 10th anniversary, which it doesn't seem like that long.
I agree. 2015, well, which is pre-COVID, so there was an event in the middle of that.
Yeah, which we worked through because people can do this at home.
All at home. I love it. I absolutely love it.
For this event, we really wanted to get 23 stations on 23 in Hobart.
I love it.
And in fact, we got 29.
More than that. Let me
substantially
go to here.
More.
So there you go. So 10th anniversary.
And here's all the stations in Hobart. There's actually 30 on that list because one station had 2 call signs, which we're only going to count as one.
Right.
Okay.
I love it.
Who all participated. And the 23 centimetre QSO party has also taken off after a couple of years in Launceston.
Oh, yes. Well and truly.
And
Did you get Launceston's?
Yes. So the next slide is.
I love it.
We had 6 stations in Launceston, so 35 altogether.
Okay.
They similarly run FM straight after the broadcast.
Okay.
Up there. Normally they only get 3 stations on.
Okay.
But they rustled up a few more who had 23 centimetre capability
I love it.
and got 6.
And now Matt VK7MAT is working out how he can get in on the action as well. So
Well, I will show you next slide.
oh, okay. You want to go to the next slide?
Yes.
Oh,
Now
you go.
you'll see here, once we've finished our FM North and South for Launceston and Hobart, we tried digital contacts with Q6560B between Hobart and Launceston. And
There you go.
so you can see here VK7PD, he's fairly strong, sort of -6s and things like that. And KWB 0 and +1, he's in Longford. So,
okay. Okay.
And he's got a better takeoff than people who are in the valley and Launceston.
Well and truly. They've got Mount Barrow in the way and a few other things.
Yeah. Now, the thing that surprised me, I got a call sign I wasn't expecting, VK7MAT.
Here you go, Matt. Now Matt's on.
Matt's
He's-
on, is
yeah,
he?
Yeah. So
What surprised me is, if you look here on the waterfall, this is Matt's signal, and it's just peaking part of the time through.
Okay.
And it's obviously peaking quite strong because you can not only see the stronger sync tone, you can also see all the message tones.
There you go.
I put that down to the fact there must have been an aircraft crossing at the time.
Just hold that thought to the next presentation.
Yeah, and you can also see some Doppler shift on it. So it was,
Yeah. Okay.
and that's probably, I mean, all that 60 seconds. So the period the aircraft was in play was probably only 5 or.
Well, Matt sent through on the Discord channel his profile to you, and it's atrocious.
Right. Yeah. Yes.
So I have no doubt that's probably aircraft, and that'd be about the only way that you'd get over the rather large mountain that's in the middle.
I'll be very interested in what he got from me, because I think he was only running a 9700 barefoot. But he might be able to.
Well, I'll just hold that thought, because I'll go back to, because I'm pretty sure Matt was on. Yes, he is. So Matt, you can try something in the chat to see. Let us know whether you actually received anything and what level it was. So hello David. So let us know. Now, were there any more slides on that?
No, but just go back to it, because I'll just say a little bit more on that. What I always also do is unfortunately, because of family reasons, VK7DW wasn't able to get on.
Andrew, yep.
But he normally does come on of a Sunday morning.
Okay.
And his situation is right down in the valley in Launceston.
Okay.
And the best he can do is beam at Mount Arthur.
Oh, okay. Yeah.
And get back all
So,
the way to Hobart.
East,
Yes.
effectively.
And I mean, the signals are never very strong. I typically work him at -28 or -29.
Okay.
But it may be that Matt. Well, I think the thing we should do with Matt is, at some stage, not during the Sunday morning, I should transmit continuously, and he should.
Find out where the stronger signal's coming from.
And find out whether Mount Arthur is the right spot or
Spot on.
something else is
Okay.
the right spot for
Okay.
where he is.
Yep.
And that might fix it.
Because one of the things I did, I actually emailed Peter Dowd, so PD, and asked him what they did for the FM contacts around Launceston
On 1296.
on 1296. They point at Mount Barrow. So they have a
Mount
Barrow.
Barrow. Okay.
So because they point almost directly south at Mount Barrow, and Mount Barrow on that side has quite a decent face on it.
Right, it's got the TV towers too.
Yep, correct. But directly below where the air services facility is, there's a huge cliff, very much like
Right.
our organ pipes. So that's what Peter said. That's what most of them do. There's a couple like KWB at Longford where they actually have to turn the beam. But yeah, that's
Now,
they do a similar thing.
if you look at the waterfall, there was this nice peak, but I also got a decode up here,
Okay.
and that nice peak actually got to -21.
Okay.
But and then this was -24, but I actually decoded Matt again.
Okay.
But I assume that. Well,
Cool.
I think if he had that barefoot, I should have been 10 dB stronger, and so I assume he was probably copying me most of the time. But we didn't complete a QSO.
Okay.
But I'm counting him as one of the
No.
participants
Well, truly.
for the 23cm QSO party, and I think one of the beauties of the 23cm QSO party.
Rex was -20 to me.
Yeah. Okay. Was it continuous?
I was pointing direct to Rex, but I didn't try pointing at Mount Barrow. I moved my Yagi between 180 and 90 degrees.
Oh, 90
So-
should have gone to Mount Arthur.
Well,
So,
truly.
yeah.
So
well,
maybe you test where you constantly transmit, and then Matt finds out where he's getting the best signal from. So
yes.
that's probably.
I
a
mean,
good
this sort of improvement is what everybody has sort of done when they've come on the QSO party and
well, truly.
fixed antennas and worked out where to point and how to operate and and so forth.
I love
So
it.
that's one of the benefits of it. Okay.
That's
well,
why we've now got 20. We had 29 on, and we've got 49 possible stations.
That's right.
Just in the south.
And I know of a couple that we tried to get on who forgot or didn't turn up. So
Dear, oh dear.
I think we could have easily got up to 40.
Okay.
Some of the 49 are not that active anymore, but yeah. Okay, then we'll go to another presentation.
Now, this is absolutely fascinating. So,
Okay. This is aircraft scatter at 6 and 2 metres. Now, most people on the mainland are quite familiar with aircraft scatter. It was first exploited by VK3UM and VK2ZRH on the Melbourne to Sydney route, where you get a lot of aeroplanes.
well, truly.
They didn't call it aircraft scatter because they were sort of listening and they had weak tropo, and they both had, I think, a sort of 4-bay Yagis at both ends.
Oh, okay. So a decent amount of gain.
And a
okay.
decent amount of power.
Okay.
So they could tell there was a weak tropo signal, and every now and then they'd get a stronger signal,
Okay.
and they started to find that related to the aircraft flying up and down.
Okay. Now this is voice, I assume. This is
voice,
voice,
because
yeah.
2ZAB won't use digital. Well, he's passed away. In fact, both those guys have unfortunately passed away.
correct.
But So it was digital, and 2ZAB interestingly calculated, and how you do this off voice I don't know, with variable amplitude, but sideband, he calculated that the signal was about 20 dB stronger than it should be for radar scatter.
Okay.
And
Okay.
at the time he thought he'd discovered something new, and there were a whole lot of articles in AR in the 1980s about this, where people were guessing it was caused by reflections under the wings, or the ionised gases behind the jet engines.
Yep. Okay.
Or the warm air causing refraction behind the aircraft, and so forth. Now, about 2000, I actually published a paper on this for Gippstech, informed by the fact that one of my colleagues at the Bureau of Meteorology was a radar guru, and he drew my attention to some work that had been done on aircraft forward scatter.
Okay.
And the interesting thing about aircraft forward scatter, you get a lot more gain than the normal backscatter radar reflection, which sort of explains it. Now, Gordon and Doug sensibly said, I'm getting an enhanced signal when there's an aircraft, so they called it aircraft enhancement.
Okay.
And it's common for the people on the east coast of Australia to refer to it as aircraft enhancement.
Okay.
But in terms of the physics of it, it's
scatter.
It's scatter, and it's forward scatter.
And the enhancement is the forward scatter.
Yeah. And the reality is, forward scatter was first defined at light optical wavelengths by Professor Mee in Germany.
Mee scatter.
Yeah, in 1912
MIE.
he published it, and then the first evidence of it being used at radio was the US Navy set up a 60 meg link across the Potomac River, which I think feeds into Washington.
Yep. Yeah.
And the idea was, if any enemy ships were going to come into the harbour,
would have detected them early.
This would cause a break in the signal. And when they actually recorded the signal, they got a peak and some sidebands, and they said they didn't really understand that this was really what you'd expect out of forward scatter.
Yep. Yeah.
Side lobes, rather. And it wasn't until that was in 1922, and in about 1928, the US Naval Laboratories, the penny dropped, and they realised they were actually dealing with forward scatter at radio waves of a ship.
Okay.
And now, I don't think there's a lot of evidence that there was any work done after that on radio forward scatter off aircraft.
Okay.
Until a paper was published by Professor Siegel in the USA at an aeronautical conference on aircraft forward scatter.
Okay.
And he developed all the theory and what you can expect.
Okay.
But he dealt with this as if it was all at optical wavelengths, which means the body that's blocking the wave
is huge.
It's got to be much larger than the wavelengths.
Correct.
And he concluded that you could actually get an increase to the fourth power of the change in frequency.
Something for nothing.
Yes. Now, the only trouble is the more you go up in frequency, the forward scatter lobe gets narrower and narrower.
Okay.
Which is how you get the gain.
Yep. Yeah.
But the lobe then doesn't get back to the ground because it's too narrow.
Yep.
and so you finish up having to use either minor lobes or, in some cases, if the aircraft's flying towards you, you're using thinner sections like the wings, which are much thinner and can produce still decent forward scatter lobes that are broader because the narrower the wings are.
Okay.
So he published that, and I used that paper as the basis for explaining that it wasn't all these things that people
Thought it was.
Okay. But aircraft scatter is actually blocking of the wave front and the wave diffracting forward. And as the two waves, if you do it in 2 dimensions, as for instance a wave passing an island, the two of them join together, and after the island, they add, and you get an
enhancement.
You get 6 dB. 3 dB, 3 dB. But in the case of an aircraft, it's actually not in 2 dimensions, 3 dimensions. So you're getting this diffracted signal all around the aircraft, adding up.
Okay.
And you can actually get signals the order of 20 dB. Once you get more than 20, you usually have got to a frequency that you can't get it back to the ground, depending on what distance you're going.
Yeah, okay.
So in practical terms, 20 is about the limit that you get.
But 20 dB enhancement's pretty
That's
incredible.
right.
Wow.
That's pretty good. And I have actually done an aircraft scatter all the way up to 24 gigs.
Yeah. Okay.
So, given that I went to QTech and we talked about, for the optical stuff, the forward scatter, and someone came to me and said, what's the difference between forward scatter and aircraft forward scatter and aircraft enhancement? And I said, they're the same thing.
They're the same thing.
And it occurred to me that there's still a lot of misconceptions about what actually causes it.
Okay. And
what I thought I would do, I started some experiments so that I have some solid results with Brody VK3MAP in Victoria. And I thought I'd compare 6 metres and 2 metres, because I knew that 6 metres wouldn't have nearly as much enhancement. But using Professor Siegel's results, it should have only been about 18 dB down. And now we'll go on to the next slide.
Okay, here.
So that's the aircraft that we used. It's a big aircraft, a Boeing 777 300. And because it's flying across the path, it blocks a lot more energy than if it was flying towards you, because you've got the whole fuselage. So you get a decent signal off it. And
it just happens to be right in the middle of between you and Brody.
Which is something that doesn't happen very often, because unfortunately these aircraft fly from Auckland to Perth, and depending on the instructions they get from air traffic controllers, they can fly over Hobart or Melbourne or one of the islands or through Strawn.
So what height are we talking? 35,000 feet? Is this
sort of yeah.
Okay.
Righto. So we've got to be very lucky to get an aircraft in the middle of the path. So it's a bit of a painful exercise. We can, of course, at higher frequencies, we can do it on aircraft flying from Melbourne to Hobart. The difficulty is at 6 metres and 2 metres, the Doppler shift is so low on a path that's almost in line, because it sort of, the Doppler to and from cancels.
Oh, correct.
And so
it's basically flying the path that you're transmitting on.
Yes. So you can't really separate the tropo from the aircraft scatter. So you need the ones that are going across. So I thought, well, we'll compare 6 metres and 2 metres. And the next slide.
Down. Cool.
shows you. Now this was, can we point to something? Oh, yes. Yeah, this is 2 metres, and you can see the aircraft is the slanted path.
Is this line here?
And you can just see by the amount of redness, it's much stronger than the troposcatter, which
Is going in and out along this path.
That's right. And at the same time, we did it on 6 metres, and there is absolutely nothing.
Well, explain what those little red lines are.
These little red lines are like here and here and all here. These are meteors, reflections at 6 metres. Now, meteors work quite well at 6 metres. They're more difficult at 2 metres.
Meteor pings.
But there are meteors at 2 metres here and here.
Yep.
Oh,
No, hang on. Let's go backwards.
and they sort of equate to these meteors here and here.
Yep.
Now, unfortunately, Brody wasn't GPS locked on 6 metres, so we don't know exactly where either the tropo or the aircraft should have been. What we do know that on 6 metres, the slope on the aircraft would have been 1/3 of what it was on 2 metres, but there's no evidence of it at all. And
That's bizarre.
your first reaction is,
Something was wrong with the system.
someone wasn't receiving, someone wasn't transmitting. But the fact that we got
The meteor pings.
all the meteors.
Just explain what these little artifacts here are.
Yes.
Here and here.
Those little artifacts, if you look up at the frequency scale at the top, are exactly 100 hertz either side.
Yeah, which is telling.
Which I absolutely certain means they are 50. If you rectify 150 hertz AC in your power supply with a bridge rectifier, you actually get 100 hertz hum.
Correct.
And it looks like either Brody's receiver or my transmitter has got a fair bit of hum. It's not that strong, but
you only get that when there's a really strong signal.
That's right.
So right on where it crosses the path, you obviously got a very strong signal.
That's right.
So okay, cool.
So that's the first conundrum.
Definitely.
Now, what I then did is I fed these files into Spectrum Lab, and that allows me to measure signal to noise ratio, and I'll have to qualify how I do that in a minute, but for the moment you can see there was a peak right up here just at the time the Doppler actually crossed the path.
Yep. Okay. Huge peak.
And that peak was 41.3 dB above the noise. So it was a massive signal.
Rock crushing.
And in order to get the Doppler out, I had to divide spectrum up into 3 parts. This red part was all the signal that was above the tropo.
Yep.
The green was what was below the tropo, and the orange was my best at of the strongest signal around the tropo.
Okay.
Now, in fact, when it's right on the path, it's so strong that the tropo is not really part of the story.
Yeah.
But you have to divide it up in 3 to isolate
Okay.
the Doppler, otherwise you get a very noisy trace.
Yep.
There are little lobes like this which are characteristic of what happens when you're well into the optical region of aircraft scatter.
Okay.
Because in the horizontal dimension, the aircraft's actually about 74 metres long. So that's many wavelengths long, so you get a lot of But in the vertical direction, at 6 metres, it's only...
what, a wavelength and a half or something?
Yes. So you get a very broad in the vertical.
I'm trying to think what's the diameter of a 777 in the middle?
Probably about 6 metres, I would have thought.
Yeah. Yeah. Okay. Because the 777's, that's got the 4 and 4 seat arrangement, hasn't it? In the back, I think, from memory.
I'm not sure exactly, but it's
quite
big,
a wide aircraft.
It's a big aircraft. That's right.
Okay. Wow.
So we then I thought, well, I want to try and see if I can actually see a 6 metre aircraft, a 6 metre aircraft.
Okay.
So I did a test with Peter, 7PD.
Yep.
Oh, now, before we do that, let's. This is the relative system performance.
Okay.
And we had slightly lower power on 2 metres, but
more gain on.
We had more antenna gain on 2 metres.
Yeah.
You've got more capture area on 6 metres. You've got a lot more noise on 6 metres.
Okay.
And the end result is you should be 7 dB difference, which is not a lot of difference.
Okay.
Doesn't explain 40 dB to nothing.
Yeah. You'd be expecting to see something on that 6 metre
Yes.
chart.
So if you apply Professor Siegel's formula for the forward scatter gain, in this case it came out at 18.32, but 18 dB.
Improvement on 6 metres.
Improvement on 6 metres, which still doesn't explain 40 dB to nothing.
Correct. Okay.
So we then went and did a test with Peter, 7PD. Now, it's the same aircraft, and it's near the middle, but not quite.
Okay. Okay.
And it's the same Boeing 777-300.
So they've been told to fly closer to Hobart this time.
I didn't tell them, but
No,
somebody did.
Yeah, or the winds were better further down or something.
Yeah, and I think it went through Strawn or something like that.
Okay.
You got to be very lucky to get the aircraft to fly where you want it,
Right.
and you only get one chance a day.
Yeah. Okay.
And now, here is 6 metres. We didn't do it on 2 metres at the same time.
No, but
but
there's something there.
There's something there.
Mm.
And in fact, it was 33 dB in the middle.
Wow. So that's the enhancement. That's the level of enhancement.
Now, at 6 metres. Now, if you take account of the distance, it's inverse square law to the aircraft, and it's inverse square law from the aircraft to the other end.
Yep.
So that's 40 log the difference in the distance, and it's 165 kilometres to Peter.
Yep.
And 506 to Brody MAP.
Yep.
So you would expect the signal to be 19 dB stronger.
Yep.
It's the difference of, however, it was dramatically stronger because it was 33 dB stronger over nothing. And the 19 dB, it's 19 dB stronger compared to nothing.
Yeah.
It's clearly not explaining why.
You didn't get anything on 6 metres.
Yeah, and why it's so dramatically strong to Peter.
Okay. That's 33 dB, even with the loss to and from. So the actual signal is it's off the show.
The tropo's not that strong. Look, that's,
no. You get bits that are strong, but nothing like when it's the aircraft.
Yeah.
Wow. Okay. But that still doesn't explain why you didn't get the 6 metres
No.
and the 2 metres.
So, now this is the same sort of plot, and this shows you that Peter's signal actually got up to about 33 dB. So, still very strong.
For quite a long time, actually.
These are minutes, so it's still only about
Half a minute.
Which is a
So
function.
for two-thirds of 30 seconds, it was up at above 30
dB, yeah.
Okay.
Wow.
Big aircraft.
Yeah. Now, the tropo, I should explain how I'm measuring signal to noise. I want to find the frequency of the Doppler, and so I look for the peak frequency above or below the tropo.
Okay.
So that the tropo's not
An influencing factor.
influencing it. Then I also, around the tropo frequency, I know that the aircraft's going to be strong, so the aircraft will dominate the tropo anyway.
Yep.
So whatever I see, so I actually, this is red above,
Yep.
orange in the middle, and green below.
Okay.
And you can see that the Doppler is fairly good.
Yep.
So most of the time, it's actually picking up the Doppler.
Yep.
But by looking for the peak in, say, the 30 hertz above or 30 hertz below,
Yep.
there's a chance that on average, or that some of the time, the noise will be strong.
Yep.
And then you get an odd frequency that's away from the Doppler because the noise overloads it.
Okay.
But you can still see clearly.
That line fits.
That's right.
Well and truly.
So then the question is, the only explanation I can think of is that at 6 metres you get ground nulls because your antenna, depending on the height of your antenna above the ground, you get a signal reflected off the ground which cancels the direct signal.
Okay.
And
So it's like selective fading.
yes, and those nulls depend on how high in wavelengths your antenna is.
Okay.
And it sort of works out, it's very hard to work out how the null gets a real null right at 0 elevation.
Okay.
And it gradually goes up to a lobe. Now, the lobe works out about 19 degrees for 6 metres.
Okay.
And about 3 degrees for 2 metres.
Okay.
Now, when you look at the aircraft at halfway between me and Brodie, there's a very good chance that aircraft's only subtending an angle of about 3 degrees, which is well into the lobe on 6 metres, but not on 2 metres.
Okay.
And it's possible
that you're getting the null
at both ends.
Okay.
Now,
so how much is how much attenuation?
Well, the null is only absolute if you have a perfectly flat ground that's perfectly conductive at the frequency,
which neither end would have.
Neither end, but when I asked Copilot what you really could expect, he said really about 6 dB at either end and no more than 10.
And at those sort of signal strengths, you'd still be seeing something.
Yeah. Well, no, if you take account of, we've got 40 dB, then you take the 18 dB off the 40.
Yep.
and then you take off. Well, if you take off 10 dB at both ends for ground nulls,
28 dB.
At both ends.
Oh, okay. Okay.
It might just, it might.
Get to 0.
Yeah. Now, the other thing is, if we go back here, the method of measuring signal to noise means right over here where there's really no evidence of Doppler, I've got noise level coming out at about 8 dB. So perhaps it's not really 40 dB above 0, it's 40 dB above 8.
Above 8, yeah. Okay.
So there's lots of little bits that might explain it. But
I'm just surprised you didn't see anything.
that's all I am.
Just
so
anything.
I am too. Now, clearly what I've got to do is I've got to repeat this experiment a number of times.
Yep.
And Brodie, in fact, is at present in Tasmania on a holiday.
Well, that's inconvenient.
And he visited me Monday and Tuesday.
Okay.
He hired a very big caravan, and he imagined getting that in my drive.
Okay.
Yeah.
I know your drive.
Yes. In order to get the caravan level, he had to put his car into my garage. And it wasn't too bad driving up the hill and into.
But how's he going to get it out?
Well, yesterday he did. So.
Oh, okay, righto. You still got a post box?
Well, we were thinking of trying to lift the post box out, but it was too hard to lift. So, at the moment, he's somewhere on the east coast where all the bushfires are.
Oh dear. Okay. Yes.
So, he'll be back home on about the 14th of December, and then I've got to go to Melbourne for my.
Oh yes, for Christmas.
No, for my granddaughter's
graduation.
graduation.
Yes. Okay.
So sometime in the future we will repeat this experiment. Now I did get Copilot to look up whether anybody else had done aircraft scatter on 6 metres, and he said VE3VN reports 6 metres using FT8, which is not nearly as sensitive as single tones,
Well, truly.
to 800 kilometres. Now, whether it just means he's on top of a big hill or with a very high antenna or something, but the answer is more testing is required.
Well and truly. I love it.
Yeah.
I love these sort of things. This is good. This is very good.
So,
Okay.
yeah, so I don't know the answer, but I think we've got something interesting to look into.
Well and truly. And what's the difference between PD and Brody?
I think the main difference is because the aircraft's the paths are shorter, the aircraft is higher. We're both beaming
the
at
angle's different.
We're both beaming at the aircraft at a higher angle, which means that
The ground null.
the ground null is not in play. If it is the ground null.
Okay. Well, you can test that. That's highly testable.
How?
Well, by repeating it. Oh, yeah. Okay. You need to be able to change that angle.
And I've got to tell the aeroplane to fly at different heights.
No.
I mean, significantly high.
No, significantly, which is not going to happen.
Yeah, please fly at 70,000 feet rather than 35,000 feet.
No. Okay. Well, but the plane. You said the plane potentially changes its location.
Yes.
So if you were able to find at this end or at Brodie's end another station,
Yes.
where you can change that angle.
Well,
Yeah.
the difficulty is I need somebody in the middle about straight.
Yeah, no, well, that's, okay. On the back of the Spirit or something. Yes. No.
Or Flinders Island or King Island or something.
Oh, actually, that might work.
Yeah, but we haven't really got any VHF.
I don't think we do.
Yeah.
Okay. Interesting.
Yes.
Absolutely fascinating, Rex, as usual.
Thank you. I am just fascinated too.
Oh no, well and truly. I can see a Hamicon or a Gibbs Tech. I keep saying
well,
it.
I did mention
Q-Tech.
to you I'd like to talk about this at, but it doesn't really fit your theme.
No,
so
there's a technical stream, well and truly.
Okay.
Well and truly.
Yeah.
Well and truly.
But hopefully we'll have some answers by November.
Well and truly. Fantastic.
Okay.
Thank you very much, Rex. That is excellent. And I look forward to more tests when Brody's back.
And Peter.
and Brody, if you're around the place and somewhere near the club rooms or whatever, please. Oh, mind you, it's the 14th.
I did bring him up to the club rooms on Monday.
Oh, okay.
But I didn't have a key, so
okay.
I couldn't get in.
No. Okay.
At least I showed him where our club is.
Well, because he's been on the stream a few times. That's when he's...
Okay.
Yeah.
Yeah, I don't think he'd be on while he's touring around. But I mean, he could be. Yeah.
Okay. Fantastic. Thanks, Rex. Can you send Warren in, please? And this is VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our DATV Experimenters Night. And I'll just take a quick look. Hello to Andy and Darren up in Mount Isa, and we've got Andrew down at Kettering and David DBX. So welcome, and we've got Matt. And yeah, I think organising with Rex a continuous receive and find out where it's happening.
Good evening, Justin.
Hello. Now, did you bring the Kia?
No, unfortunately, I haven't.
Oh, okay. No, that's all right. That's okay.
I come unprepared.
No.
But
Take a
happy to join in for a second and
take a seat.
Oh, you have a nice picture of it. Yes.
Yes. We'll leave this for next week.
Yeah, so we have a Kia here. Which camera are we on?
Yes.
That one there?
Yep.
And
tell us a bit about this particular Kia, Warren. I'll do a close-up of it over here.
yeah, okay.
This is, we've got our doc cam. Oh, and our doc cam's frozen. I love it.
Oh,
Don't you hate that? Like there's absolutely nothing. No, okay. We'll stick with this.
Yeah, can we sort of zoom in?
Yeah, I can actually. We have this technology. There you go.
Hold it right there. That looks pretty good.
Look at that.
So
tell us a bit about this particular squeeze Kia, as it's called.
Okay, well, this goes back to the early 70s, and I was living in Germany at the time, and nearby was an amateur radio club.
Okay.
And I got interested in amateur radio.
Okay.
And
as you do.
I guess one of the spin-offs or side effects of that was that I got interested in Morse code, and these devices were available on the market.
Okay.
They're basically a paddles Kia, or they call them a squeeze Kia. So with the two paddles, you can squeeze them together, and you get the da-da. But there's no processor in there, no CPU.
It's TTL.
Just TTL logic.
It's
and yes. So I acquired one of those and had fun starting to learn to. Well, I didn't actually transmit Morse code, but I was learning Morse code, and I could actually put out a few characters with that.
Okay.
And then as I decided, I might move to another country, and I was getting ready to shift out to Australia, I kind of had like a household garage sale or so. I got rid of all my stuff, and this Kia was gone, sadly. Well, so I thought, but then many decades later, I suspected that I knew who might have bought it off me.
Okay.
A guy who is a ham
Yep.
in Germany.
Yep.
And I contacted him. I said, did you happen to buy this Kia off me? And he said, yeah, would you like me to send it over? And it turned out that a good friend and former classmate of mine was coming over to visit from Germany.
Okay.
So he packed this thing in a suitcase, and now I have it back again, which is absolutely wonderful.
I love it.
And so, yes, the plan is to bring it in here and present it on one of our evenings.
Yep.
And I guess we'll just leave it at that for now.
No, okay.
So,
That is fantastic, and what a story! It's a bit like Hamfest, really. Hamfests are about redistributing. Some would say redistributing the junk, but that's some. But it sort of makes its way around through different shacks and may wake its way back to you.
yeah.
Oh no, well that's excellent. In this case, it came all the way back from Germany. Oh my goodness.
So, when you search thoroughly enough online, you'll actually find the this bit of data. So, appreciate the fact that that you've been able to print this out.
Oh no,
and,
well and truly.
and bring it in. So that'll be very useful, and we'll see when we can schedule this.
Well and truly. Now, the other thing I wanted to mention as well, and it's good that you're in the studio, is David Brunet, who is FT4YM/P, and the P is he is portable at or around Concordia Station.
Our French friend.
Our French friend, who has been down a few times. But he is down at Concordia Station right at the moment, and every so often you see him come up on FT8.
Mm-hmm.
And so if you've got your ham alert utility on your smartphone or whatever device that you're using, I have actually got his call sign in my ham alert.
Mm-hmm.
And so when somebody actually makes a contact with him, and it's logged through a variety of different ways, PSK Reporter and the Reverse Beacon Network and a few other bits and pieces. When his call sign comes up, I get an alert, and it tells me that FT4YM/P has just made a contact with whoever. So that's how I know he's on 20 meters, or he's on 40 meters, or he's on 18 meters or 17 meters or whatever else. So that's how I found
Yeah, and if
out.
I recall correctly too, with ham alert, I think it picks up spots that people put on, like
Well and truly.
DX Watch or whatever.
Absolutely.
And if it turns up there, then you also get an alert, and he's on air at the moment.
Well and truly.
Yeah, let's.
And I did an FT8 contact with him. Actually, an excellent FT8 contact. I think it was like -8 or something on 20 meters about a fortnight ago. I think it was a fortnight ago. So conditions were absolutely perfect.
That's great. Yeah.
So and that was with the magnetic loop too. So my cunning plan of using the magnetic loop worked.
Yeah, that's great. Yeah. So is David still down there?
As far as I
we
know.
speak?
Yeah.
Okay.
Although I actually haven't had a spot from him for quite a while, so I don't know whether he's in transit on the way back, or he's in transit. He could actually be on one of his traverses
Yes.
to get the 1,000,001 year ice core.
Well, 1 million and 2.
Yeah, well, he used
years
to make
now.
it 2 because the Australians are doing 1,000,001. And I did see the Antarctic Division posted a whole lot of pictures around their traverse that's going on right at the moment. Because they were I think they were going to Dome C. Now
Yeah.
that's where Concordia is, isn't it?
Correct. Yes.
Yeah,
so,
yeah. So,
yeah, so Dome C is like I may stand corrected, but I believe Dome C is like the third highest dome or hill or plateau on the ice. So you have Dome A.
okay.
Actually, don't know anything about Dome B or so. Dome C. Yes, is Concordia, which is the joint Italian-French station.
Very impressive looking station if you look it up.
Yeah, it's very remote in the middle of nowhere.
Nowhere.
And it takes a number of weeks to traverse, like from Casey Station up to Dome C.
Correct.
And yes, so the winter that I spent at Casey, what now, 22, so it'd be 3 years ago. Yes, there was, even back then, a lot of preparation work was being done to take the traverse stuff up there.
Yep.
So yes, this million-year ice core project has been sort of a work in progress for quite some time. Every year there's been some delay of one sort or another, but yeah, it's finally happening
It's
now.
happening. And there's a multi-tractor, multi-sled, traverse. There's a lot of equipment being taken there. Yeah, not an insignificant amount of effort and resource gone into this. So
And countries are watching each other too. And I spent time in the mechanical workshops at Casey fitting comms equipment and radios to the tractors that pull these traverses. And I was kind of overhearing chit chat from the DSOs how these tractors, in order to pull that load, they need to have like counterweights on the front so that their tracks really
so they
grip
don't
the ice.
flip.
So they have weights on the front and they have weights on the side. And they were discussing how the French distribute the weight differently.
Okay.
So they're kind of watching each other how they do it.
I love
Which I thought was kind of cute. In a
Well,
way.
and David posted some pictures, and one of the tractors is the side tracks are sort of down in a ditch, and it's on a precarious sort of angle. So I'm not quite sure what happened there.
Yeah, I'll have to look that one up. Maybe they managed to come across a crevasse or something like that.
And it dropped into it, but yeah. Anyway, so
Yeah.
I just wanted to say, please keep an eye out and a ham alert ear out for FT4, so Fox Tango 4 Yankee Mike /P, because if you see him come up, he's you can get a card, and we got a card. We got a Concordia station card that had the stamps on it. It had the postage stamps on it. Both from, now it was from it was a unique one because it had the Concordia stamp on it, it had the Casey stamp on it, and it had the Wilkes stamp on it, the aerodrome.
Yes. So these cards traveled with him, and at the various locations at the time, he added the local stamp to it. So
I love it.
Yeah, so
it's quite a unique card.
Very much indeed.
Quite a unique card.
Yes,
so
that's good.
prize that card.
Yeah. Okay. Well, we'll get this Kia in
Fantastic.
sometime, and we'll have a good chat about
Next
it.
week. Next week.
Yeah.
We-
So next week will be another regular.
Yes. Yep. So
DATV.
regular ATV night, and in fact that is our last one for the year, because if you look at your calendar, the next one after that will be Christmas Eve, and I'm sorry, but we're not having one on Christmas Eve.
But that's not like you. Are you having a?
if I had one on Christmas Eve, I think I'd be not able to get inside anymore.
I would see the gallows in
Yeah.
South over.
I would be popping my rooftop tent somewhere, and that would be it.
So there are limits at home. Then.
Oh yeah.
I thought, yeah.
So yes. So there's one next week, and we've got a bucket load of material for next week. Now, the space weather, I'll just do a quick space weather report. There was a significant CME event that threw an awful lot of energy at us, but fortunately, it missed us. And what I'll do is next week I'll actually show you Dr. Tamitha Scove, who is the space weather woman, for those who don't know. She posted a modelling, she's got a modelling arrangement where she can model those events in 3D, and you can zoom through them and zoom up and zoom down and all sorts of stuff. So she posted a really interesting model of what happened, and you can see why we fortunately didn't get the main energy from it. It went to a G3, a geomagnetic storm 3, level 3, but that was yesterday, and it's gone back to a 1. So yeah, very quickly that energy passed us, so which was probably good, but absolutely fascinating. So no significant space weather to report. And the only future event that I just want to highlight is on the 18th of January. So we come back from into 2026. Now we don't have one on New Year's Eve. that was the next one that we would have had. We're not having one on New Year's Eve, but the week after that, so I think it's the 7th, we will be having one. And then on the 18th, which is Sunday the 18th, we've got a huge Carboot sale up here, amateur radio Carboot sale. So we've got Carboot, and we've also got sausage Sizzle, so you can come up, grab buy a snag or two, and peruse the redistribution of treasure.
Yes. Okay, so 2 weeks in a row, Christmas Eve and New Year's Eve.
They happen to fall.
No activity up here.
No.
In the studio.
Fortnight of break,
Wow.
and then we're back, and we're back for the rest of January with Wednesday Experimenters Group nights. So
Yes.
yeah. So one more to go, and then we've got a 2-week break.
Definitely got to put it in my calendar that there's going to be a Carboot sale, because I'm a sucker for buying
18th.
stuff.
The 18th.
Maybe I should try and sell something for a change. And
Actually,
yeah.
so should I, actually. Now, can you just reach into there? There is a green valve, a green variant valve. Now, I just want to show you this, because this is one of the things that I want to go into next week. This is a valve. Now, this particular valve is a little bit unique. This is absolutely brand new and has never been used. Now, I just want to leave you with this. This particular valve is capable of generating a small amount. It's only small power, but quite a bit of signal on 5.9 to 6.2 gigahertz.
So this looks like a waveguide, isn't it?
It's a waveguide flange.
Wow.
So this is what they call a reflex klystron tube, this is for military applications. It has absolutely never been used. It's brand spanking new. Nothing's been connected to any of the pins. Nothing's been screwed onto the wave.
Looks immaculate.
The waveguide. But I just like to point out this is a valve that generates about 6 gigahertz of energy. Not very much of it, but 6 gigahertz of energy, and it's a valve. So just hold that thought. I'll leave you with that. So that's our show for now. I'll just zoom back out again there. That's our show for now. Look after yourselves. Thank you, Warren, for coming in. Well, I look forward to our squeeze Kia.
And I believe, membership renewals have been announced.
They have. They've been sent out. You'll be getting those automatically from Tidy HQ, our membership system. So,
and then February or March, there'll be an AGM. Is that correct?
The 15th of February. Sunday, 15th of February.
Halfway into February.
Yep. Yeah.
AGM.
And that'll be a AGM, and then we'll have barbecue.
Woohoo!
So it's a Sunday, straight after the broadcast, we go into the AGM, and then we have a bit of a member barbecue after that. So
it's our new barbecue.
New barbecue. we showed our new barbecue the other night because it was sitting in the middle of the club room's floor. Now let me just go like and back again. There's a whole bunch of people, as you can see, in the club rooms. So they're chatting away. All sorts of stuff going on. So anyway,
Very good. Okay.
that's your blooming lot. 73, and enjoy your week, and we'll catch you up with you next week. Cheers.
Catch you.